Our next speaker is Teddy Nakato. Teddy is a master's student in renewable energy at the Makerere University in Uganda. She's working on the Faecal Sludge Management Prizes project. Her interest is in fecal sludge as a fuel.
Thank you so much, Dave. Teddy Nakato, and specifically I was looking at the fuel potential of fecal sludge, and in this I was characterizing the calorific value of sludges from 3 different cities in Africa. So this is just a part of a big project that is called the FEM project, Fecal Management Enterprises. And this project is carried out by 5 countries and 6 partners, that is Austria, Switzerland, Senegal, Ghana, and Uganda. So we all know the challenges, sanitation challenges in developing countries, that when we actually get the pits full, you find that most of the sludge is dumped into the environment or trenches, and when they are floods, then it creates health risks. So this is because most of the people cannot probably afford paying for emptying, or even those who try still have the problem of accessibility, like you can't access the latrines, the trucks can't go through, so there's a big challenge. And you find that even with improved systems, the sanitation is not provided in the communities. So there is a need to actually manage the fecal sludge from on-site sanitations, and we are looking at adding a value to the end product. And this would help remove the fecal sludge from the communities, and also would ensure adequate treatment. So one of the possibilities we looked at was using the fecal sludge as an industrial fuel, a fuel that could be used like any other biomass fuels in industrial processes, because there is a big demand in most of these cities, and we hope that since the fecal sludge is readily available and renewable, then it could easily be used to co-combust with the available fuels, or even replace the use of fuels. So in this we tested the technical viability of converting fecal sludge to solid fuel by evaluating the effects of the source of the fuel, like fuel from pit latrines, septic tanks, lagoons. We also looked at the effect of the age of this fecal sludge and the calorific value of the sludge. We looked at predictors of calorific value like COD, and also evaluated the effect of dryness on the fecal sludge, because it's important to deliver this fecal sludge drier so that it can be used by the industries. So calorific value is the main metric that we used to determine the potential energy of the fecal sludge, and this is mainly the quantity of heat that is produced by combusting a fuel. So in this study we were comparing results from 3 different countries, Senegal, Ghana, and Uganda, and specifically we looked at Kampala in Uganda, Kumasi in Ghana, and Dakar in Senegal. That is comparing fecal sludge from West Africa and East Africa. So from these 3 cities, they all have a population of over 1.5 million people, with Kampala having 1.72 and Dakar 2.51, of which the population served by sewer lines is about 7 in Kampala, 8% in Kumasi, and 25% in Senegal. The biggest population is serviced by on-site sanitation systems, with 86% in Kampala and Kumasi, and 72% in Dakar. And in all the 3 cities, we still have a problem of open defecation, with 7% in Kampala, 6% in Kumasi, and 3% in Dakar.
Thanks.
So we looked at Faecal Sludge from various categories of latrines, and we looked at fully lined latrines. Those are latrines that are cemented all through, and then unlined, those are like they have soil underneath, so there is no concrete. Then the partially lined, then the septic tanks that are commonly used. And then we also looked at Faecal Sludge from drying beds, and drying beds were filled with raw Faecal Sludge directly from trucks, and also sludge from wastewater treatment plants. So we also looked at sludge from anaerobic ponds, and then fresh and dry heaps. These are heaps of sludge that has been excavated from anaerobic ponds, and then there were also some non-functional ponds that were sampled. So this is just the source of our sludge. We got sludge directly from the trucks, and then we got sludge from the drying beds, and these drying beds were filled with raw Faecal Sludge from the trucks, and then sludge from wastewater treatment plants, and then from anaerobic ponds and heaps. From the drying beds, we actually sampled on the first day. The beds were filled, and then for 3 consecutive weeks to just compare the effect of dryness on the calorific value of the sludge. In this, we can see how the samples were collected. Trucks were followed to the point of collection, and just to ensure that actually a particular category of sludge was collected. And then they were followed back to the disposal sites, and samples were collected at the beginning, midway, and at the end of emptying, and a composite sample was made. And from the drying beds and ponds, we actually picked samples from 5 different locations, and then a composite was made, and this was delivered to the lab, in which several parameters were tested. We have calorific value, water content, total solids, and COD, amongst others. So from the results, we actually compared sludge from like septic tanks and fully lined pit latrines across the 3 cities, and we realized that there was no significant difference by type, that is, sludge from septic tanks and fully lined pit latrines almost had the same calorific value with no significant difference. And also, in comparing sludge from like the different cities, we still found that the difference was not that big in terms of calorific value. So we also took averages of the calorific value of this Faecal Sludge from different cities, and the first one is like the average of Kumasi, Faecal Sludge, Dakar and Kampala, and also like sludge from the wastewater treatment plants. In this, we wanted to compare the calorific value of this sludge with that of traditionally used biomass fuels, because we have so many industrial processes, and since there is a shortage of fuel, you find that they resort to using different biomass fuels, and these include like rice husks or old money paper, wood, sawdust, coffee dust, groundnut husks. Yeah, and we just wanted to see how Faecal Sludge fares with these traditional biomass fuels in terms of calorific value. So we also compared like the age, and we looked at the age and how it affects the calorific value. And in this, we looked at samples like from septic tanks, unlined and fully lined and partially lined pit latrines. And we realized that the age of the Faecal Sludge did not actually significantly impact on the calorific value. So this is very unusual, and because we expect some degradation, so we actually think probably there are some complex organic compounds that were actually degraded slower or not degraded. and we think probably we'll have to do some more research on this and see which compounds are these and what type of energy they give off. So we also looked at COD as a predictor of calorific value, and we realized that even when in the drying beds there was a reduction in COD from about 80 to 40 milligrams per liter, still the calorific value was consistent. So we still think probably there are some organic complex molecules that were not oxidized during the COD test. So we hope that probably we'll look more into this and try to find out which compounds are resistant, and because they have an energy impact on the process. So fecal sludge for industrial processes needs to be drier for it to be used. So we actually looked at the total solids of this sludge, and looking at our results, septic tanks mainly have very low total solids. This is because they receive a lot of grey water as compared to other pit latrines like the unlined, which have like leaching and drainage of this water into the soils. So they have a more concentrated fecal sludge as compared to that of septic tanks. And from like the drying beds, you find that the total solids kept on increasing with time because of the drying of the time and space in order to improve on the energy balance. But the form and dryness of this fecal sludge is definitely important for its use in the various industries. So this will actually determine the different treatment processes that should be carried out. Because you find that some industries want the sludge as powder, others need it as pellets, depending on the usage or the kilns that are being used, or if they are to be used in improved stoves, so they need it in different forms. So that determines also the different treatment processes that should be carried out. So in conclusion, the calorific value did not vary significantly with the source of this sludge, like from pit latrines or anaerobic ponds. And also the age was not a predictor of calorific value. Calorific value also compared of fecal sludge as compared to other biomass fuels competed well and is similar, so which means it can easily be co-combusted with these biofuels, or it can even be used to combust in various industrial processes. COD was not a predictor of calorific value in this case, but we also realized that still the dryness and form of this final fecal sludge is very important in this aspect for the use and profitability of using fecal sludge as an industrial fuel. I would like to acknowledge the funders of this project, and I thank you so much.